Hello everyone, welcome back. In this video, we will look at key length and key space. Before we jump into details, let us look at the credit card PIN number. Most of the credit cards or debit cards have a PIN of length 4. That means you could pick up to 4 numbers. Things might change in future, or some of the banks might have already implemented a longer PIN, but in most cases what you see is a 4-digit PIN. Now when it comes to 4-digit PIN, you have 4 positions, and for every position you have an option of 10 digits, meaning from 0 through 9. So for each position you have 10 possible values, so you have 4 positions. Mathematically you can calculate by using the formula 10 raised to the power of 4 gives you 10,000 possible combinations. And you might be thinking all 9s, which is 9,999, but where did we get this one extra from? Or because I am saying 10,000, that is because all zeros is also a possible combination. That's why you get 10,000 possible combinations. But the max value you could have is all 9s. The minimum value is all zeros. So if you have a credit card and if you want to crack it at an ATM machine, you might start with all zeros and go all the way through all 9s, and you will crack it. However, the bank might lock it after 3 or 4 attempts. So now that's what is a brutal attack. So you will literally sweep through the whole possible set of values, and you attempt to crack it. Now before we jump into the key space, key length, when it comes to encryption, let us talk about a binary system in just 30 seconds. A binary system is a numeric system where you have 2 numbers, 0 and 1, period. That's it. You don't have anything else, zeros and ones. Probably you might have heard many times that computers are all about zeros and ones. Yes, that is true. Now, what is a bit? A bit is either 0 or 1. 2 possible values. So when we said a credit card PIN number, it's a 4-digit PIN, and each digit has a possible values of 0 through 9. In this case, when you say binary system, all you have is 0 and 1. Well, with that introduction, let's jump in. Now when it comes to key length and key space, you'll also hear key size. So let us take an example, analyze it, and then I'll explain you, or at least show you, what key length and key space are. Take an example of 3 bits, so 3 possible positions. Now, as we have already discussed, each position has 2 possible values because it is a binary system. 0 or 1 are the values. Now, how many combinations do we have? 2 raised to the power of 3 gives you the total number of possible combinations. The length here is 3. When you say 3 bits, 3 is the length. The possible values in this particular case is 2 to the raised to the power of 3, which is 2 times 2 times 2, which is 8. So that 8 possible values is the key space. It is easy to visualize when you say 3 bits, but when we go to higher bits, it kind of becomes a little difficult. So let us talk about it. The example here is 128-bit key. So you have 128 possible combinations. Now, what do we know? Because it is a binary system, we have 2 possible values, 0 and 1. Now, 2 raised to the power of 128, that gives you the number of possible combinations. In this case, the length is 128 or 128 bit. You can also call it size. Now, when it comes to space, key space is nothing but 2 raised to the power of 128. And you get this gigantic number. I will not even try to say that number. Now, the scientific notation is 3.4 times 10 raised to the power of 38. Now that's an approximate value, so that's how you would write in scientific way. Anyway, so the key point here is when someone says 128-bit key, that is the length or the size, and when they say space, what they really mean is all possible combinations. Now most of the algorithms, when they say they implement 128-bit key, that really doesn't mean that they have a total of 3.4 times 10 raised to the power of 38 possible combinations. No, they will exclude some, like all obvious things like all zeros, all ones, few things will be taken out. So it will be little less than possible value that you could get from the scientific calculation or mathematical number. It will be little less than that. Most of the algorithms do that. Well, that's it about key length and key space. Just to quickly to recap, a 128-bit key, 128 is the length, or you can also call it size. And when you say key space, it's all possible combinations. And in this particular case, you would get 2 raised to the power of 128. Well, what did we do? We looked at key length and key space. Well, that's it in this video. We'll see you in the next.